Hello, good morning dear students. Welcome to Interactive Virtual Class Nagaland once again. I hope all of you are doing well. Alright students, so in today's class we will look into new chapters, okay? But before we go into the chapters, let us see some incident, okay? So here we see a boy coming back from school, okay? He is washing his hands. Now after washing his hands, okay, he said to his mother, "Mom, I am hungry." Okay, then the mother brought him some snacks, okay, some sweets and water. Okay, now after eating these sweets, the boy said, "Wow, mommy, it's very delicious." Okay, then the mother replied saying, "Of course, my son, it is made from pure ghee." Okay, it is made from pure ghee. Then again in another incident we see here two women, okay, talking to one another. First woman says, "Wow, that is a very pretty necklace." Okay, then she asks the other woman, "How much did it cost you?" Okay, how much did it cost you? Then the other lady replied, "It cost me rupees 80,000." Okay, it cost me rupees 80,000. Then the other lady replied, "Really? It's that? How is that very expensive?" Okay. Then the other lady replied, "Of course, necklace is made of pure gold, so it is very expensive." Okay. Again here we see two boys. Okay. One of the boys asked the other boy, "Is this water drinkable?" Okay. Then the boy replied, "Yes, it looks clean and pure." Okay. So in all these cases, we see that they are saying that it's pure ghee, it's pure gold, it's pure water. Yes. So in ghee, ornamental gold, drinking water, they are saying that it's pure. But are they really pure? Okay. Not only this, there are so many materials around us, there are so many substances around us which we consider it to be pure. Yes. But are they really pure? We will find out in today's class. Okay. So in today's class we will start with this chapter, that is matter around us pure? Okay, we will start with this chapter, is matter around us pure? Now before we look into this chapter, let us quickly recall this. Okay, this question is already taken in our previous classes, so let us quickly recall this. The question is, matter is anything that occupies space and has dash. Okay, I'm giving you 15 seconds to respond to this question. Students, your time starts now. Matter is anything that occupies space and has dash. Option A is volume, option B is mass, option C is weight, option D is density. Which of the following option is the correct answer? Alright students, your time is up, and yes, very good. The correct answer is option B, that is mass. Matter is anything that occupies space and has mass. So in today's class we will be discussing, is matter around us pure? Now we have revised on what is matter. So matter is anything that occupies space and has mass. In today's class we will discuss whether matter around us is pure or not. Okay, so let us see here. So here we have sea, water, ghee, milk, air. These are all matter around us. So are they pure? Yes. Let us see. Okay. So here, after the conversation between the mother and the son about pure ghee, okay, the father was laughing. Then the son asked, "Daddy, why are you laughing?" Okay. Let us see what the father will reply. Then the father replied saying, "Pintu, many things we see in our surroundings are not pure." Okay, scientifically, okay, the father added, "Scientifically, ghee is not a pure substance. Ghee is a mixture of fat, protein and many other substances." Okay, so here we learn that pure ghee is not pure. Okay, ghee is not a pure substance, it is a mixture of fat, protein and other substances. Now the father also added saying, "Scientifically, even drinking water is not a pure substance." Okay, it consists of different minerals. And the father added saying, "Generally, almost all substances are mixture of different components." Okay, so the matter around us are not pure, they are mixture of different components. Okay, so here we see sea water. and here we see sand and stones, and here we see the air, okay, the air around us, okay. So here we see that sea, water, sand and stones, air, all these matter around us are also not pure, but they are known as mixture because they are composed of one or more substances, right? So mixture, these are the example of mixture. Sea, water, sand and stones, air, these are examples of mixture. So what are mixtures? Mixtures are constituted by more than one kind of pure form of matter known as a substance. Okay, mixtures are constituted by more than one kind of pure form of matter known as a substance. Okay, so here we have sea, water. Example. Okay, some example of mixtures includes sea water. Sea water, it consists of salts, water and some minerals. Okay, another example we have here is we have water and salt. Now when we mix these two, we get mixture. Yes, we get mixture. Now what happens when we heat this mixture of salt and water? Okay, when we heat it, we see that at the end only salt remains. Yes, so we see that we mix salt and water together. We were able to separate salt and water. The water evaporated, yes, due to evaporation. So at the end the salt remains. Yes. So what are mixtures? We have seen that mixtures are constituted by more than one kind of pure form of matter known as substance. Okay? And mixture can be separated into its components by physical methods. Okay? So water. We have seen that water is a mixture. So water consists of minerals like calcium, magnesium, potassium, sodium, etc. Okay, we have seen that soil is a mixture and it consists of minerals, organic substances, air and water. Now another example, air is also a mixture. Okay, air is also a mixture. It consists of nitrogen, which consists of 78% of air, oxygen, which is 21%, water vapors, carbon dioxide, argon, etc. So air, the air present around us is also a mixture because it consists of one or more substance. What about salt? Okay, what about salt? We know that salt is made up of sodium and chlorine. Yes, salt is made up of sodium and chlorine. Sodium chloride is itself a substance and cannot be separated by physical processes into its chemical constituents. Okay, remember mixture can be separated by physical processes. Okay, but sodium chloride itself is a substance and it cannot be separated by physical process into its chemical components. And so sodium chloride, okay, and their composition, the composition of sodium and chloride in salt is same throughout. So such substances are called pure substance. Okay, those substances whose constituents, okay, cannot be separated by physical methods, and if they have same composition throughout, such substances are called pure substances. So salt is a pure substance. Okay, another definition of pure substance, a pure substance is one which is made up of only one kind of particles. Okay, examples are 24 karat gold is a pure gold, distilled water is a pure water. Okay, so a pure substance is one which is made up of only one kind of particles. This is one definition. Another definition from which we can understand pure substance is that those substances which have same composition throughout and whose constituents, okay, whose components or constituents cannot be separated by physical methods are called pure substance. Another example is salt. Okay, so this is what pure substance means. Alright students, we have another question. Please get your rough devices ready. The question is, which one of the following may be termed as a pure substance? Giving you 15 seconds to respond to this question. Your time starts now. Which one of the following may be termed as a pure substance? Option A is sodium chloride. Option B is soft drink. Option C is aerosol. Option D is soil. Alright students, your time is up. We have seen that soil is a mixture of different minerals. Yes. Soft drink is a mixture of water, carbon dioxide. Aerosol is also a mixture of different gaseous particles and other small solid particles. Sodium chloride, we have seen that it is made up of sodium and chlorine. But it has the same composition throughout, and its composition cannot be separated by physical method. So here the correct answer is option A, that is sodium chloride. Very good students. Now let us see. Take example of this. Okay, let us take water in one beaker and salt. Okay. Now when we dissolve this salt in this beaker, what happens? The salt will dissolve in water. We get salt plus water. So now this has become a mixture. Yes. Another example is potassium permanganate. Potassium permanganate, when we dissolve in water, okay, when we add into water, it will dissolve and the color of the water changes. So we have potassium permanganate plus water. Now let us take potassium permanganate, 1 spoon of potassium permanganate and 1 spoon of salt and mix them. Okay, mix them. What happens? So we mix them, salt plus potassium permanganate. So we have 3 cases here. Salt plus water, we get salt plus water. We have potassium plus water, and we have salt plus potassium permanganate. So what do we observe here, students? We see that in the first 2 cases, that is salt plus water and potassium plus water, there is even distribution, right? When you dissolve salt into a water, whether the water is at the top of the cup or at the bottom of the cup, you will taste the saltiness equally. Yes, if it is dissolved. Similarly, for potassium permanganate and water, we see that the color of the solution at the top and the bottom is the same. So there is even distribution in these 2 cases. Whereas in the third case, salt and potassium permanganate, when you mix these 2, we see that in some portion we see more amount of salt, in some portion we see more amount of potassium permanganate. So there is uneven distribution. Yes, so these even distribution are known as homogeneous, and the uneven distributions are known as heterogeneous. Okay, so mixtures are broadly classified into 2 types. One is the homogeneous mixture, and the other is heterogeneous mixture. Homogeneous mixture, homo means same and hetero means different. Okay, so what are homogeneous mixture? Mixture which has a uniform composition throughout are called homogeneous mixture. Okay. Alright students, before we proceed further, let us answer one more question. Please get your rough devices ready. The question is, solution which has uniform composition throughout is called which of the following? I'm giving you 30 seconds for this question. Your time starts now. Solution which has uniform composition throughout is called, option A is homogeneous, option B is heterogeneous, option C is colloidal solution, option D is none of this. Yes students. Alright students, your time is up, and yes, very good, the correct answer is option A, that is homogeneous solution. Solution which has uniform composition throughout is called homogeneous solution. Very good students. Now let us take another case. So now take some amount of salt and put it into the water, dissolve it. Okay, dissolve it. Then take copper sulfate. Take a spoon of copper sulfate, add into the water, and again dissolve it. Then take some potassium permanganate and dissolve it in the water. So those are the examples of homogeneous mixture. Okay, when you mix salt and water, the composition is same throughout. Okay, so it is a homogeneous mixture. When you mix copper sulfate in water, it has same composition throughout, so it is a Homogeneous mixture and potassium permanganate in water, they have the same composition throughout, so they are also example of homogeneous mixture. Okay, so here homogeneous mixture may have, okay, or can have a variable composition. These are all homogeneous mixtures. Okay, these are all homogeneous mixture, but we see that the concentration of potassium permanganate here is more. The amount of potassium permanganate here is little less, it gets lesser, but these are all still homogeneous mixture. So homogeneous mixture can have a variable composition. Okay, so what now? Coming back to heterogeneous mixture, what are heterogeneous mixtures? Mixtures which contain physically distinct parts and have non-uniform compositions are called heterogeneous mixtures. Okay, so example is, take water and pour some amount of salt into the beaker. So mixture of sand and water is a homogeneous mixture because the particles of sand will settle down at the bottom of the beaker. We will see that the composition of the salt in the water is not same throughout. Yes, another example is air. Air is or smoke. Okay, smoke is an example of heterogeneous mixture. Then we have water and oil. Okay, when you try to mix water and oil, you will see two separate layers, meaning they do not have same composition throughout. So mixture of oil and water. So these are some of the examples of heterogeneous mixture. Okay, so let us see the difference between homogeneous and heterogeneous mixture. Homogeneous mixtures are those mixtures which has uniform composition throughout, whereas heterogeneous mixtures are those mixtures which contain physically distinct parts and have non-uniform compositions. Examples of homogeneous mixtures include salt in water, copper sulfate in water, and also potassium permanganate in water, etc. Example of heterogeneous mixtures include sand in water, smoke, oil in water, etc. Okay. Alright students, we have another question. Please get your rough devices ready. The question is, choose the homogeneous mixtures from the following. Okay, I'm giving you 30 seconds for this question. Your time starts now. Choose the homogeneous mixture. Option A is wood, option B is blood, option C is charcoal, option D is sugar syrup. Alright students, your time is up. Wood is not a homogeneous mixture. Blood is not a homogeneous mixture. Charcoal is not a homogeneous mixture because the composition of the constituents are not the same throughout. However, in sugar syrup, it is a homogeneous mixture because the composition is same throughout. So here the correct answer is option D, that is sugar syrup. Very good students. Now activity. Okay, differentiate the below mixtures into homogeneous and heterogeneous mixtures. So let us see one by one. Okay, the first is sand and common salt. So when you mix sand and common salt, will it be homogeneous or heterogeneous mixture? Yes students, very good, it will be heterogeneous mixture because the composition will not be same throughout. Yes, you will see distinct parts of sand and common salt when you mix them. Air, we have seen that air is an example of heterogeneous mixture because there are different particles present in the air which are not in the same composition. Coffee, yes, coffee is an example of homogeneous mixture because its constituents like sugar, milk, coffee are in same composition throughout. Okay, another example is fruit salad. Fruit salad, is it homogeneous or heterogeneous? Yes students, very good. Fruit salad is an example of heterogeneous mixtures. In fruit salad, it consists of different types of fruits which may not be in the same composition. Small stones and large stones. If you mix them, will it be homogeneous or heterogeneous? It is heterogeneous. Yes, very good, because we will see the distinct parts like small stones and large stones. They will not have the same composition throughout. So yes, from these 5 examples, we see that only coffee is a homogeneous mixture. Know this, okay? Mixtures can be of different types. solid mixtures. So when we mix solid substance with solid substance, we will get solid mixture. Solid mixture will also have homogeneous and heterogeneous. Okay, so homogeneous solid mixture example is brass, which is made up of copper and zinc. Okay, heterogeneous solid mixture example will be sand and common salt. Both sand and common salt are solid, that is why they are known as solid mixtures. Nowadays, okay, bronze, brass, nichrome are called alloys. Okay, alloys are homogeneous mixtures of metals and cannot be separated into their components by physical methods. Alloy is considered as a mixture because it shows the properties of its constituents and can have variable composition. Another example of solid mixtures is bronze. Okay, bronze is made from copper, zinc and tin. All these are solid. So this is also example of solid mixtures. Another example is amalgam. Okay, amalgam is a mixture of mercury and sodium. So this is also another example of solid mixture. Another example is stainless steel. Stainless steel is made from iron, chromium, nickel and carbon. Okay, so this is also another example of alloys. Okay, these are some example of alloys. Another example is solder. Solder is made from lead and tin. Okay, so this is also another example of alloys. Next we have is solid liquid mixtures. So when we mix solid substance with liquid substance, it will be called solid liquid mixture. Homogeneous solid liquid mixture example is salt in water. Salt is solid, water is liquid. So when we mix these two, we get solid liquid mixture. Homogeneous, one example of homogeneous solid liquid mixture is salt in water. Then we have heterogeneous solid liquid mixture example is water and sand. Then next we have is liquid mixtures. When we mix one liquid substance with another liquid substance, we will get liquid mixtures. First we have homogeneous liquid mixtures. Example is water and ethyl alcohol. When we mix water and ethyl alcohol, both are liquid. When we mix them, they will have the same composition throughout. So this is an example of homogeneous liquid mixtures. Example of heterogeneous liquid mixtures is water and oil. Both water and oil are liquid. When we mix them, they form two separate layers. So this is an example of heterogeneous liquid mixtures. Gas liquid mixtures. Example of homogeneous gas liquid mixture is water and ammonia. An example of heterogeneous, okay, this should be heterogeneous. Example of heterogeneous gas liquid mixture is air. Okay, so these are some of the examples of homogeneous gas liquid mixtures and heterogeneous gas liquid mixtures. Activity. Okay, another activity, students. Take a beaker containing 50 ml of water and add one spatula full of copper sulfate powder. Another one is take a beaker containing 50 ml of water and add one spatula full of chalk powder or wheat flour. Okay, then another is take a beaker containing 50 ml of water and add few drops of milk or ink. So we have copper sulfate in water, wheat flour or atta in water, okay, and milk in water. So we have three solutions here. Okay, now before we proceed further, let us answer one more question. Please get your rough devices ready. The question is, which of the following is a heterogeneous matter, okay, or heterogeneous mixture? I'm giving you 15 seconds to respond to this question. Your time starts now. Which of the following is a heterogeneous matter? Option A is sugar solution. Option B is sugar and salt. Option C is salt solution. Option D is all of this. Alright students, your time is up. Now let us see. Sugar solution is a homogeneous mixture. Salt solution is a homogeneous mixture. Sugar and salt, when we mix them, they will not have the same composition throughout. So here the heterogeneous matter will be sugar and salt. So the correct answer here is option B, that is sugar and salt. Very good students. Now solutions. Okay, what are solutions? Let us see. So when we mix copper sulfate, okay, or when we dissolve copper sulfate in water, we get copper sulfate and water. Yes. When we dissolve copper sulfate in water, we get copper sulfate solution. Yes, students. So a solution, okay, a solution is a homogeneous mixture of two or more substances. Okay, a solution is a homogeneous mixture of two or more substances. All homogeneous mixtures are called as solution. Okay, example, we have water and salt. We have copper sulfate in water, and we have potassium permanganate in water. Okay, so salt in water, copper sulfate in water, potassium permanganate in water. These are examples of a solution. Okay, these are all solutions. So we can say that this is salt solution, this is copper sulfate solution, and this is potassium permanganate solution. So a solution is a homogeneous mixture of two or more substances. All homogeneous mixtures are called solution. Another example is ammonium hydroxide and phenolphthalein. These are also examples of solution. Alright, students, we have another question. Please get your rough devices ready. The question is, a homogeneous mixture of two or more substances is called. Giving you 15 seconds to respond to this question, students. Your time starts now. A homogeneous mixture of two or more substances is called. Option A is solution. Option B is solvent. Option C is alloys. Option D is none of them. So which of the following option is the correct answer? Alright, students, yes, very good. The correct answer is option A, that is solution. A homogeneous mixture of two or more substances is called solution. Very good, students. Now let us see. So in a solution, okay, in a solution we have seen that salt dissolved in water makes a salt solution. So the component present in lesser amount, okay, and that is dissolved in other component is called solute. Okay, so here we are taking salt and dissolving it in water. So salt is present in smaller amount, lesser amount, right? So salt is the solute. Okay, and the component present in larger amount and that dissolve the other component is called solvent. Okay, so in a solution we have solute and solvent. Solute is present in lesser amount and that is dissolved in other component. Component present in larger amount and that dissolve the other component is solvent. So here salt is the solute and water is the solvent. Okay, now types of solution, let us see here. So brass is a homogeneous mixture, so it is a solution. The type of solution is solid. Here the solute is zinc and solvent is copper. The next we have is vinegar. Vinegar is the type of solution is liquid. Okay, here the solute is acetic acid and solvent is water. The next we have is soda water. Soda water is gas liquid solution. Here the solute is carbon dioxide and water is the solvent. Then in salt solution we have it is a solid liquid solution. The solute is salt and solvent is water. Okay, so differentiate between solute and solvent. Solute is present in lesser amount and it dissolves in other component. Solvent is present in larger amount and it dissolves the other component. Okay. Properties of solutions. Let us see properties of solutions. So a solution is a homogeneous mixture. The composition will be the same throughout. The second property of solution is the particles of a solution are smaller than 1 nanometer, so they cannot be seen by naked eyes. When we dissolve salt into water, we cannot see the particles of the salt. Yes, so the particles of solution are smaller than 1 nanometer, they cannot be seen by naked eyes. The third properties of solution is they do not scatter a beam of light through the solution. Okay, so even when you pass light through the solution, they will not scatter the beam of light. Then the fourth property we have is the solute particles cannot be separated by filtration method. Once you dissolve the salt into the water, even when you try to filter it, you will not be able to separate salt and water by filtration method. Concentration of solutions. Let us see. So the solutions having small amount of solute is said to have low concentration. It is known as dilute solution. Okay. So when only small amount of salt is present in the water, then it will be less salty. Yes. Then we will say that it has low concentration of salt, and we will say that it is a dilute solution. Okay. So the solution having small amount of solute is said to have low concentration. It is known as dilute solution. Examples are dilute hydrochloric acid, dilute sulfuric acid, and dilute nitric acid. The next is we have the solutions having large amount of solute is said to have high concentration, and it is known as concentrated solutions. Example are concentrated hydrochloric acid, concentrated H2SO4, concentrated nitric acid. So when we say concentrated, it means it contains large amount of HCl and less amount of water. Okay. When we say concentration, it means it contains more amount of solute, and when we say dilute, it contains less amount of the solute. So here we have potassium permanganate solution. Here the amount of potassium permanganate is very high. Yes, so it has high concentration, and here the concentration of the amount of potassium permanganate is very less, so it is dilute solution. Potassium permanganate solutions of varying concentration. Okay, so here we see that concentration decreases. Yes, decreases from this side because less here more amount of potassium permanganate, and here we have less amount of potassium permanganate. So this side are concentrated solution, and towards this side are dilute solutions. The concentration of a solution is the amount of solute present in given quantity of the solution. So we can know the concentration of the solution by knowing the amount of solute present in the given quantity of the solution. Now let us see here. Again, water in a take water in a beaker and salt. Okay. Now dissolve it. At first it rises to 52 ml, then after dissolving it again decreases to 50 ml. Now add more amount of salt. Again the volume of the water increased to 52 ml. After some time it decreases to 50 ml again. Now what will happen if we keep on adding the salt? Will it keep on dissolving, or will it stop at one point? Yes, students? Let us find out. Alright. So now after some time, even when we try to dissolve the water, dissolve the salt in water, it stops dissolving. Yes, so if we keep on adding salt into a cup of water, when you keep on dissolving, at one point the salt will stop dissolving. Why is this so? It is because, okay, at any particular temperature, a solution that has dissolved as much solute as it is capable of dissolving is said to be saturated solution. It has reached saturation. Okay, so at any particular temperature, a solution that has dissolved as much solute as it is capable of dissolving is said to be a saturated solution. So this solution which cannot dissolve any more solute is known as saturated solution. Okay, or we can define saturated solution as when no more solute can be dissolved in a solution at a given temperature, it is called as a saturated solution. The amount of solute present in the saturated solution at this temperature is called its solubility. Okay, the amount of solute present in the saturated solution at this temperature is known as its solubility. Now, when we add only 1 spoon of salt into the water, it will dissolve easily, right? It will dissolve easily. Now we can add more amount of salt into this water, it will still dissolve, right? So if the amount of solute contained in a solution is less than the saturation level, it is called an unsaturated solution. This solution can dissolve more salt. right? So this solution is called unsaturated solution, whereas that solution which cannot dissolve more solute is known as saturated solution. Okay. Alright students, we have another question. Please get your rough devices ready. And the question is, in a sugar solution, solute is which of the following? I'm giving you 15 seconds for this question. Your time starts now. In a sugar solution, solute is option A is water, option A is sugar, option B is water, option C is sugar and water, and option D is none of this. So which of the following option is solute in sugar solution? Alright students, your time is up, and yes, here the correct answer is option A, that is sugar. Sugar is present in lesser amount and it will dissolve in water. Yes, so solute is option A, that is sugar. Very good students. Alright students, so in today's class we have discussed about what are mixtures. Yes, mixtures are constituted by one or more kind of pure form of matter. We have seen some examples, right? We have seen that seawater is a mixture because it contains salt, water, and other minerals. We have seen that air is a mixture because it consists of different types of gases. We have seen that soil is a mixture because it consists of minerals, organic substances, air, water, etc. Okay, so that is what mixture is. Mixture are constituted by constituted by more than one pure substances. Okay, we have discussed about two types of mixture. Yes, one is the homogeneous mixture and the second is heterogeneous mixture. Homogeneous mixtures are those mixtures which have uniform composition throughout, whereas heterogeneous mixtures are those mixtures which contain physically distinct parts and do not have the same composition throughout. We also discussed about the different types of mixture, that is the solid-solid mixture, solid-liquid mixture, liquid-gas mixture. Yes, we have discussed about the different types of mixture: solid-solid mixture, solid-liquid mixture, liquid-liquid mixture, and gas-liquid mixtures. We have also discussed about solutions. Yes, what are solutions? So a solution is a homogeneous mixture of two or more substance. Okay, a solution is a homogeneous mixture of two or more substance. All homogeneous mixtures are solution. Okay, we have seen the example of brass. Yes, under solution we have also seen the solid mixture, liquid mixture, gas liquid mixture, etc. We have seen the different properties of solutions. Yes, we have seen that a solution is a homogeneous mixture. The particles of the solution are smaller than 1 nanometer. We cannot see the particles with our naked eye. The solution does not scatter beam of light, and the solute particles cannot be separated by filtration method in solution. We have also seen the concentration of solution. We have seen dilute solutions and concentrated solution. Dilute solutions are those solutions which contain less amount of solute, whereas concentrated solutions are those solutions which contain large amount of solute. We have also discussed about saturated solution, unsaturated solutions. Yes, saturated solutions is the solution when no more solute can dissolve into the solution at the given temperature, whereas in unsaturated solutions, when the amount of solute present in the solution is less than the amount of solute present in saturated solution, it is known as unsaturated solution. We also define solubility from this. Yes, the amount of solute present in a saturated solution at a given temperature is called its solubility. Okay, so at saturated solution, in saturated solution, the solute, okay, the amount of solute present in the solution is maximum. No more solute can dissolve into the solution if it reaches the saturated solution. So these are the some of the points that we have discussed in today's class. In tomorrow's class we will discuss more about matter and the different types of mixtures. Okay, so this leads us to the last question for today. Please get your rough devices ready and respond to this question. The question is, how do you feel about today's class? I'm giving you 10 seconds for this question. Your time starts now. How do you feel about today's class? Option A is happy, option B is quite good, option C is satisfactory, and option D is confused. Alright students, your time is up. Thank you so much for your response and thank you for joining today's class. I will see you again in our next class. Till then, take care everyone and have a nice day.